Hey there, this video is on the basics of writing your own functions in the C++ language, and this covers sections 6.1 to 6.3 in the Gaddis textbook. Now, we've been using functions all along. Maybe you didn't even realize that. All of the code we've been writing so far has been in a main function. You need that for a C++ program. And we've also been calling functions that other people have already written for us, like the pow function to compute exponents, or the set precision function, or the set width function, or things like that. So now for the first time, we're going to be writing our own functions that aren't just the main function, and we'll think about all the ways why it's advantageous to do that. So this is the big transition point in the Starter C++ programming course. So for the first time, we're going to want to write our programs in a modular style. And what that means is we're going to be separating our programs as they get larger into smaller components, smaller parts that we can focus on just one of these little parts at a time. Now, amusingly, different programming languages seem to call these parts by different names. So in C and C++, we call them functions. If you know the Java language, they're called methods there. Some languages call them procedures. The basic language calls them subroutines. There's probably some other names as well. Personally, I kind of like the fact that C and C++ call them functions because it lets me connect mentally to the idea of mathematical functions, which is more or less the same thing. So I personally kind of like that. Now, the advantages of making your programs modular are enormous. Advantage number one, it lets you avoid repeating code. And if you remember from earlier, do not repeat yourself is always going to be our number one philosophical guide to writing a good program. That's really kind of the whole point to software engineering or using computers in the first place. So that right there, if I can avoid repeating code and reuse it, that right there is probably going to make my day all on its own. But in addition to that, it means that as you focus on one of these sections, there's going to be less to remember at once, and that's good, right? We can't, in our heads, memorize a 1,000-line program. So having a little section that's maybe 7 lines long, maybe 10 lines long, will really help give us mental focus. Third, it's easier to test and fix a program in small chunks. If you run a big long program and it has errors and the program is just 1,000 lines long, where's the error? Where am I going to go to fix it? I don't know. But if you have a separate small function that controls that particular thing that you just changed, it'll be very easy. Go in that section, and that's where the errors got to be, and it'll be much easier to find the bug and to fix it. Item number 4, your functions can be reused by other programmers. So if you're working on a fairly big team, you do some kind of job, like, I don't know, print a bunch of data perhaps, and you write it in a function, and then other programmers can just name your function, like we've named the function pow in the past, and that job will automatically happen for them, and they don't actually have to write any code for it. Brilliant. And fifth, on that same theme, it allows us to separate the work assignments among many programmers. So if we have these well-defined subsections, we can parse them out to different programmers and have them all work on the separate parts at once. And that's how most software engineering workplaces actually do their job. Let's take a look visually at what that looks like. So on the left here, we have a program that has one long, complex main function, and that's what we've been doing so far, frankly. We've just had this main function, and inside the curly braces, we have all of our statements, and our programs are starting to get longer and longer, such that A, it doesn't even fit on the screen all at once, and B, you certainly can't memorize all that stuff at once. And C, if there's a bug or an error, you're going to have to be hunting through a whole lot of stuff to try to find where it is. So that stuff on the left, don't do this anymore. Nobody writes programs like that with just one giant main function with all the statements in it. It is too difficult to manage and maintain. Nobody does that. We should expect never to do that ever again. For students in my course, for assignments, don't do this. We'll never do that again. What you do want to do is the structure on the right. This program here, the problem has been divided into smaller subsections, smaller problems, each of which is handled by a separate function. So here we have a main function, again with its curly braces, and that main function only has 3 statements in it. Great. Anybody will be able to look at those 3 statements and very quickly understand what's going on. And then you have function 2, right, with its own curly braces. And for this example, that also has 3 little statements, very easy to understand. And there's function 3 with its own couple of statements, and there's function 4 with its own couple of statements. So maybe the main function controls everything, and function 2 controls the input, and function 3 controls the processing maybe, and function 4 might control the output. So if there's an error in the output, it'll be very easy to say, hey, the bug must be in function 4. I'll just go hunt in those 3 statements and very quickly find the error. Or if you need to modify something about the output, that's the function that you're going to change. In addition to that, again, if I have a workplace with multiple programmers, maybe today we've designed this and we say, okay, Alice, today you need to go write the main function. And Bob, you're going to write function 2. And Kathy, you're going to write function 3. And Dennis, you're in charge of function 4. And you all go on to your workplaces today and you work on those little subsections that you can think about in isolation, and then we'll put them together at the end. And that's how the work would be done, actually. So this, on the right, this is what you want to do from now on. That is a modular program, and that is how we should expect our programs will always look forever from now on. And that's what professional programs look like. If you look at a professional program, that's what you're going to see on the screen is a bunch of separate functions like that. Okay, so now we understand why we want to modularize our programs, and now we'll think about how to write a function. Basic idea of a function. So a function means a predefined collection of statements, maybe just a couple, to do one specific, well-defined task. Right? A function should do one thing, one single job. And the basic idea is very much like math functions. This is exactly where this idea comes from. So again, this is why I like using the word function in C++ for it. So you're in a math class and you define a function like this. F of x is equal to 2x cubed. So from now on, we know what the function f is going to do. If I see in a piece of math writing after this point, after it's been defined, like f of 2, right, f parentheses 2, I can mentally jump into this definition. I can say, okay, that 2 is getting used in place of x, and then I can move over to the right here, and I can do these operations in the correct order of operations, and I can say, okay, what's going to happen? Now the x is being replaced by 2, because that's what you wrote in the parentheses, and I can do 2 cubed, which is of course 8, and then I can multiply that by 2 and get 16, and then I can come back to the piece of math I'm actually working on with that 16. And that's exactly how computer functions are going to work in C++. You have a definition first, you jump into it with some kind of data, you run the statements, and then you return probably with one value like that 16. And that's what it says here. When a function is called in a C++ program, the program flow jumps into that function, executes the given statements in the normal order, and then jumps back probably with one return value, just like a math function does. Now, the thing that I want to emphasize, right, the whole reason we're doing this is we want functions to be short enough to view and understand in just like one look at it. So they definitely, my recommendation is they definitely need to fit on one screen, right? The start and the end, the whole thing needs to fit on one screen so a programmer can just view the whole thing from start to finish and see what that function is doing. I would suggest an ideal, this is me talking, I would suggest an ideal of around 7 lines per function. 7 lines is kind of my gold standard. Now, if you write a function, it's 3 or 4 or 5 or 6 lines, that's perfectly fine. If it's 8 or 9 or 10 or 11, 12, it's perfectly fine. But it definitely should fit on screen at once. Why do I say 7 lines? Well, there's a psychological principle called the rule of 7 plus or minus 2. And based on experiments, we find that most people, most human beings, can hold in their short-term memory about 7 things. Some people a few less, some people a few more. So if you write your function with about 7 statements in it, most human beings can hold those things in their head at once and understand what the whole function is doing. So there's a lot of variation around that. Some people would maybe say other stuff, but the point is it needs to be short, right? The goal is to have it short enough that any person can just see the whole thing and hold it in their brain at once. That's what we want. Okay, so hopefully I've convinced you why you want to introduce functions in your programs and why they exist in any kind of professional code. So in order to add a function to your program, there's going to be 3 elements, and this slide's about the first one. In C or C++, you need function prototypes, probably at the top of your code file that look like this. There's going to be some data type attached at the beginning. There'll be a good name for the function, and then there'll be parentheses to indicate that this is a function. So this first part is referred to as the return type. It's the type of data that the function returns at the end, like that 16 from the math function example. And then you have a good function name, and then you have these parentheses that indicate, yeah, this is a function, it's not a variable. And inside those parentheses, that's called the parameter list. So what a prototype is doing for you, again, probably right at the top of your code file, is it's specifying a function's signature so the compiler knows what it's going to look like when you call this function. It's sort of put in a table of contents, so to speak, behind the scenes for the compiler. You put this at the top of the code file, or it could be an included header file. Anytime we do #include, like IOStream, you're basically attaching a whole bunch of prototypes like this, among other stuff. So the function name, let me just kind of think about those 3 parts there. The function name uses standard identifier rules, kind of like a variable. It's going to start lowercase. You can use multiple phrases. I would capitalize, or I'd make camel case the separate words. You can't use spaces. They should be clear, easy to read English words, and it should clearly describe exactly what the function does. I usually make my functions verb phrases. Functions are pieces of code that do something, so I usually make my function names verb phrases, like get input or compute average, right? Those have verbs in them. That's probably the main thing we want to focus on today. Now, inside the parentheses, that's called the parameter list, and that's the data that's sent into the function, like the 2 that I used in place of the x in the math example, right? That's incoming data. There can be one thing coming in. There can be no things coming in. Actually, in this example right here, we left the parentheses empty. That's possible. There can be 2 or 3 or 4 pieces of data coming in. Any of those things are fine. We'll talk about that in the next video. And then this type that's at the beginning, that's called the return type, that indicates the type of data that comes back out of the function when it's done, like that 16. So that can be any standard data type, like an int or a float or a char or a bool or a string even. Or we use void there to indicate that this is a function that doesn't have any return value. We do that a lot as well. So void is the new thing you might see there if there's no return value coming back. Some people would like to call that kind of function a procedure, but in C++ we still call it a function. Now let me just say this, if you know Java programming, this is new. Java does not require function prototypes at the top of the code file because Java is just a little bit smarter. It scans the whole code file at the beginning to see all the functions in it at once. C and C++ didn't have that capacity, so you have to tell the compiler what kind of functions are coming up on your own using prototypes. Maybe at some point in the future, maybe C++ will add that capacity and then we won't need function prototypes anymore. But at the time when I'm making this recording, we still do. Okay, that's the first thing that you need for functions, the prototypes at the top of your file. Now you're going to have the function definitions where you actually indicate the statements that the function does when you call it. So that's going to look something like this. This could be anywhere in your code file. You have the header that's exactly the same as you saw in the prototype, the type and the good name and the parentheses. And then you have curly braces, just like the main function that we've been writing all along to date. I mean, the main function counts as a function in all ways. And then you have 1, 2, 3, 4, 5, 6, hopefully 7 statements, I'm hoping, in those curly braces to do that job. So that top piece is referred to as the header, and the stuff inside the curly braces is referred to as the body. It's the same terminology I've been using about the main function all along, actually. So these definitions specify the statements that will be run when the function actually gets called. As we said there, the header has got to match the prior prototype. Like I see beginning programmers sometimes get that a little wrong. Like they don't exactly use the same name in the prototype, and then there's a compiler or a linker problem. These function definitions can basically appear anywhere in the code file near the top, at the bottom, in the middle, it kind of doesn't really matter. So wherever you find it convenient or just whatever moment you think to make your function definition, it can basically go anywhere in the code file as long as you've got the function prototype at the top of your file. So this is actually indicates what the function's actually going to do. That's the second thing you need. And then the final thing, the third thing, is once you have that, now you can actually call your function just like you call the POW function or the set precision function. You just name it and put down parentheses. Right? Just here's the name of my function, put down parentheses to indicate it's a function, and that is how the code's going to go jump in and do that function. Notice that there's no return type, right? At this point, the program's going to know the return type because it looked at it when it saw the prototype. When we write POW, we don't write double POW, right? We just write POW. And the same thing is happening for the functions that you add now. So once a function is prototyped and defined, it can be called from any other function, from the main function or function 1 or function 2 or 3 or 4 or whatever. Note again that the return type is not indicated in front of the name, right? You just name it and put down parentheses, that's it. The compiler is going to know the return type, whether it's int, char, float, bool, or void, because it saw the prototype. And then when you call it here, when the code hits that point, the controller is going to jump into the function's definition on the prior slide. The statements are going to run in order, 1, 2, 3, 4. And when it hits the end of that function, control jumps back to the calling function. And that's the whole point. Okay, so those are the pieces you need to add a function to your program. Here is the first example program in chapter 6, and you see this program now has two functions. There's the main function, which has its header down on line 19, and there's also a display message function that has its header on line 10. I kind of like how this is set up. Before each function, there is a comment describing what this function is going to do. I would want to be in that habit. I require my students to do this actually. So you get this comment before display message. This is the definition of function display message. This function just displays a greeting, right? It's very easy to see what this is. The name is display message, written camel case, we like that. You got the empty parentheses here indicating a function. The return type is void. This is not a function that's going to compute a number like 16 and hand it back. And this function has these curly braces, and it only has one single statement in it. It's just this printing statement that says hello from the function display message, new line. Okay, so very, very simple to understand. We like that. And then below that now we have function main. You have a comment here saying, yeah, this is function main. As usual, the header for the main function, what we normally see, int main parentheses. And main says they're going to print hello from main. And you see line 22, that's the function call, right? We naming the function we've previously defined, display message, putting down parentheses, not writing any type in front of it. We didn't have to write void display message, and then printing back in function main again once that's over. So when this program runs, a C++ program always starts in main. So the very first line that's going to run is line 21. Always starts in main. So it'll do this, and then it will go to line 22, display message. Line 22, that function call, is going to send us up into the display message function, specifically running line 12. And then once line 12 is run, the function is over, and you go back to where you called it, which is back to line 22, and then you'll do line 23, and then you'll return from the main function as usual. Now notice that my main function, and we've seen this before, the main function has got to end with return 0, because the main function said it has this int for the return type. So at that point, you've committed that this function at the end has got to return an integer, like 0. Why? Because that's how you tell your operating system we had 0 errors. Now, this display message function is kind of different. That's a void function, which says I don't need to return anything at the end, and therefore I don't have a return statement at the end of this function. If I had a return type like int or float or bool, I would have to have a return statement just like the main function does. But for a void function, you don't need that. We should test this. Okay, so here is this program 6.1 in the IDE, and we should test it, and then I'll make maybe a couple modifications to it. So first of all, compile it, of course. That looks fine. And then I'll run it, and we'll see what it does. Pretty simple little thing, right? It prints hello from main, and then it prints hello from the function display message, and then it prints back in function main again. So based on what we said before, hopefully you could see that that's what was going to happen there. But just to be perfectly clear about that, how about we step through that in the debugger? And remember that a C++ program starts in the main function. So the very first line that's going to happen here would be line 21. Right? That is the first line in the main function. So that's where I ought to pause it initially. I'll start the debugger, bring the console over here. So a program is started. It went into the main function, as it always does. We're about to run line 21. And as I step through this, if I was in person, I would ask my students, can you predict what line we're going to go to next? So obviously, this line 21 is going to print hello from main. And then what line will we go to then? Okay, there's the hello from main. So pretty easy to predict. Of course, you're going to go to line 22. That is the normal thing that C++ programs do, is they go line 21, 22, 23, 24, unless something else happens. Now we're on line 22, and this is our function call, display message. So can you predict where we're going to go next? I'm going to click this into function button. Okay, and hopefully you can tell me we would go to line 12, which is the first line in the display message function. So that's what happens there. So you jump into the first line in the curly braces in your function definition. So we're about to do line 12 now. Obviously, that's going to print hello from the function display message on the screen. Let's watch that happen. Hello from the function display message. Great. Now you see we've hit the closing curly brace to that function. We've reached the end of that function. So as we jump out of that function, where are we going to go? Can you predict that? Where we're going to go as this function ends. So I'll hit next line and we'll see. So that sent us down to line 23 right after the function call. Right? The function call was on line 22. That line's all done now. So it sent us back immediately after the function call, which happens to be line 23. And then line 23 happens. Where are we going to go next? Well, obviously line 24. And it printed back in function main again. Right? So here we are returning out of the main function, sending control back to my operating system Windows, and returning the integer 0 to say that we had 0 errors. So the function is now at the end of this main function, and that's the end of a C++ program once you get done with the main function. So it does a little bit of cleanup work, and the program is over. Okay, so hopefully that's helpful to see exactly how you jump around based on function calls. I get what happened there. So we started on line 21, right, the first thing in the main function. We did line 21, 22, then line 12, then back to line 23, and then line 24, and that's the end of the main function, which represents the end of your program. Now let me do something else here, right? In our lecture, we said that there's normally 3 components when you're adding a new function to your code. There ought to be a prototype, there ought to be a definition, there ought to be a function call. Now this beginning program, it's got a function definition, that's here, right? That's the statements that the function does. It's got a function call on line 22 that sent us into that function. The thing that this example does not have is it does not have a function prototype. Normally, you'd see like the header on its own for a function prototype, like around line 4. This doesn't have that. Why is that? Well, you see, the whole point is when the compiler is translating your program, it just translates the program in order, line 1, 2, 3, 4, 5, 6, 7, 8, like that. And so in order for the compiler to know what a particular function call does, it has to see a prototype or a definition, some kind of function header, before that point so that it knows the scope and the signature of that function. So in this particular case, the compiler scans this file and goes, okay, I got it. I know this. That's a comment. I'll ignore that. Okay, here's a function header. I see you're going to have a function called display message. It's got a return type of void. It doesn't take any parameters in the parentheses. Got it. And so when it comes further down here and it sees that function call on line 22, it goes, I totally know how to make that happen for you. But hypothetically, what if you'd written this function definition not at the top, but maybe further down? Okay, what's going to happen here? See, now when the compiler scans the program, it goes, okay, got it, main function, I know what that is. And it's going to hit line 12 and go, I don't know what you mean by display message. I have not seen a definition for that. I have not seen a prototype, so I don't know what this is supposed to do. I don't know the return type or anything about it. And this is going to throw up an error because the compiler won't be able to deal with that. Let's see that happen. You see that? So I got this error here on that line 12. It says display message was not declared in this scope. We haven't defined it yet, so the compiler doesn't know how to handle that. And that is what the prototypes are there to solve. Let me just close this here. So the solution to that problem is up at the top of the code file to add a section for prototypes, right? And right here, I just put the header to my function. So that function I'm dealing with, it has a return type of void. It has a name that is display message. Right? It doesn't take any parameters in the parentheses. Put a semicolon down here. And so now when the compiler scans this, right, it's going it's going to see line 6 go, got it. There's a display message function, void return, no parameters, got it. And now when it sees line 15, it'll go, yeah, I know how to handle that. And then later on, it'll see the function definition to actually do what to do with it, where to jump into. And this will be fine. So I'll compile this, great. And I can run this, and it does the exact same thing as the initial program. So that's what the prototypes are for, right? And hypothetically, you could say, well, I'm just going to put all my function definitions up on top, but as you add more functions, there's going to be this spaghetti interactions of like maybe function A calls function B, and function C calls function G, and function D calls functions H and F, right? And then it becomes harder and harder to figure out which ones need to come first before what other functions. So it's much, much easier of why not just put all your prototypes at the top, and then it doesn't matter what order you put the function definitions in, just like we did here. Then you can just put them in any order that seems reasonable to you by depending on those function prototypes to tell the C++ compiler what functions are coming. So that's what I normally do. I think most of the examples in the book, that's what you're going to see from now on, and that is the issue that we have prototypes for. Again, some maybe newer languages like Java can get away without it because they can scan the file multiple times with their compiler. But the old school C++ compiler just scans it once, so you've got to have these function signatures, these prototypes, at the top. Okay, so to emphasize again what was happening for the control flow in program 6.1, right? A C++ program starts in main, right? Ran this first hello from main line. You call a function like display message, and that jumps you into that function, right? Runs those statements, jumps into that function, runs 1 or 2 or 3 or 4 statements or however many you have, and that one, when that function is over, when it hits the ending curly brace, then it sends you back to where you called it, right after you called it. And then the rest of the main function runs, and then it ends like normal. So that is what happens when we talk about a function call. Jump into it, run it. Now, this is a great place if you have access to the Gaddis textbook and the lecture code to see as many examples as you possibly can of this. There's program 6.2, there's program 6.3, there's program 6.4, and you should definitely go in the book and look at all those examples. Run those examples on your own and think about how the control flow is happening. See if you can predict the sequence of those function calls. And of course, we have examples. This example here just has 2 functions, main and display message. But those other examples will have 3 functions or 4 functions or 5 functions. And here we have the main function calling something else. But any function can call another function. So I can have functions 1, 2, 3, 4, and function 4 calls function 2, and function 3 calls function 1. And you can call any function from anywhere that you want. Okay, so I think that's a pretty good introduction to using functions and starting to split our larger programs into subcomponents and how you write the prototype and how you define the function and how you call it. So for my students, the next time we'd be in class, we would probably do this lab 6.1 on a function with no parameters. Again, to this point, we've just been leaving the parentheses empty. We haven't been sending any data into our function. We've been making a void function in all of our examples today. There's no data coming back. Those will be future videos. And in this example, we just make one very simple little function, one function call. I think what this lab does for what its sake is it just prints a message that in the olden days was used as a typing exercise. So it's kind of like an old school proverb is what happens here. So that right there is a pretty good example of getting accustomed to writing functions and thinking about the definition and the prototype and the function call, and just getting used to that, because all programs look like that if you look at real programs. So next time when we come back, the next video ought to be about using those parameters in the parentheses, like f of 2, right? Where's that 2 coming from? What are we doing with that? So next time we'll think about how to pass data into a function using the parameter list in the parentheses. So that's really important, and I'll see you then for that.